get the website to go. Okay, I gotta show you this in light of the Amazon video last week. Okay, so let's check this out. SSH Moodle at Moodle losrios.edu. Of course, the password is Moodle as well.
Oh, of course.
Yeah.
Really, I thought it was Death Star.
That'll be my home router. I have a Death Star and a Death Star 5 for the 5 gigahertz band. Okay, so we gotta look at this. Look at the uptime. 788 days. And that's the Moodle server. And then you look at the resources that is given to me. 4 gigs of RAM and 100 gigabytes of hard drive space.
So how do you do updates on there?
Huh?
How do you do kernel
Same
updates?
as every single update.
What, with the kernel updates?
With kernel updates, you still have to reboot it.
Oh, okay.
So I haven't done some, kernel updates for a while. Well, because there's no space for it. Because now, if you look at how much space it's using, the home part is the only part that has space left.
Right.
Basically /var, which is all where the database is, and also where Moodle wants to put files, is almost filled up all the way already. But it's okay. It only has to limp for another year or so. Then we have to shut down Moodle and switch completely over to Campus.
In which case you can use the space for updates.
Well, I have to find a space to park my notes. Yep.
I have 4 classes and they all use different LMSs.
Is that a problem? I mean, to a student, is it like extra problem that you have to deal with?
Not at all. I don't think it matters much. I mean,
It should not, but to some people it is. I guess it depends on your comfort level with working with different websites and technology as a whole.
yeah, I guess if I was an art major, I'd probably get pretty frustrated.
Well, you'll be surprised. Actually, you'll be very surprised, how, because the Moodle server is actually used by 2 professors in psychology as well, and we are talking about psychology 300 students, and they never have a problem with their students using Moodle. The Moodle group is interesting because we are a self-supporting community. In other words, they don't back propagate their problems back to me. They take care of their own students. They tell their own students how to use Moodle, how to turn in homework assignments, how to take exams and whatnot. And all these years, I only have the trickiest situations where they do not have sufficient rights to deal with. Like they want to find out whether a student had even signed into Moodle, and they cannot tell that. They can only tell whether a student has signed into their classes or not. So there are very few cases where I have to step in and do something. But for the most part, they're completely self-surfacing. I don't need to do much about all that. All right.
Yeah, thankfully I only have to worry about Moodle and Google Drive.
Google Drive?
Yeah, one of my professors likes Google Drive.
Google Drive is cool in many ways because I can actually type notes live in a class and share the Google Drive document with the entire class. So the best thing is if I use it in place of a whiteboard, you can scroll back to the beginning of the whole lecture and then ask questions. You can, if I let you guys insert comments, okay, you can comment right away.
Professor does is he shares the notes with comment access instead of viewing.
Yep.
And then he so that way we can add things to the notes.
Yep, that makes perfect sense. All right, so what we'll do today, I did not have enough time to actually type up the entire thing. I did have something typed up, but I think it's best if I just kind of show you guys the project and explain how it works along the way. So this is going to be mostly a demonstration, but there will be a lot of discussion of topics as well. You will be able to find this in the shared folder. The name of this particular project is Socket 1. The server encountered an error. So it's Google's turn. Nah, it's probably just a little quick issue. Nope, I signed in with the right account. Oh, it doesn't like it.
Might be an issue at the district office. I know that's where they're hosting this instance.
Yeah, they are. Well, I was just using it a little bit earlier. Well, see, I uploaded it here. Well, maybe if I can just access it from here. There we go. There we go. Okay. But I'm not sure whether you guys can see it or not. Can you see it?
I can't even load the page right now.
Which one?
Socket1.zip?
I
You
just
can,
got it.
okay. So you can go ahead and download it and open it in your Android Studio. And I'll explain along the way, where I wasted a lot of time working on this one. So that you won't have to waste your time.
We appreciate that.
Yep, it's still, maybe just my browser then. But I just started the
mine-
computer.
Yeah, I'm running Firefox as well, it's slow.
Okay. All right, so I'm gonna unzip, socket1.zip, and then we'll start up Android Studio. It will ask for an update today for sure.
It is going to.
Yeah, it's actually.
Last night I saw the needed one.
Yeah, it's an update not only for the libraries, it's an update for Android Studio itself. So this one will want to restart itself. So I'm gonna do the update first. So let's go ahead and update. It says right here it's only API. That's
The
kind
other
of
one
curious.
says-
Yeah, the studio itself is ready for an update. So let's go ahead and go. I'll go for an update first. You guys can do whatever you want to do. But I try to make sure that I stay up to date with all of this stuff here. Because otherwise, if it doesn't work, then it could be just an issue of not getting updated. So I always try to keep my stuff updated here. Check for update.
Well, it might not work because it just got updated.
That's the real decision there.
That's a possibility. Well, if it doesn't work, we can talk about Uber. Have you guys heard about Uber? All the problems that they're having right now. I think this, they may become the biggest flop of 2017 in the high tech sector because of all it's not just the magnitude; it's also from different vectors. They got a technical staff who left Google, but in a dispute. So I think that may be one major issue. And then the second major issue had to do with their workplace. So there are allegations, or there are people claiming that they have a lot of sexism going on, in the workplace. It's not very female friendly. Okay, the workplace in Uber, but that's an allegation. Okay, whether it's true or not, depends on a lot of investigation, and nobody has disclosed any result of investigations yet. And then the third problem had to do with they were doing some tests with the autonomous vehicles illegally.
Licenses.
Yes, licenses and stuff like that. So that's another one. And then last week it was just disclosed that the Uber app, along with the Google Uber Cloud service, they have some kind of special AI logic that seems to work really well. So where Uber is not supposed to operate, certain cities do not actually allow Uber because of unions of taxis and whatnot. Okay, so they do not let Uber cars operate. So when the government officials try to try to trick Uber into going like, okay, let me call Uber and see if a car would come, because if a car does come, they can just give Uber a citation. It's like, okay, you're not supposed to operate in the city. But the Uber logic is good enough that they will check a variety of things like email, IP addresses, and whatnot to determine whether this is a sting operation or not. So if they think there's
they did it a violation of the use agreement. So they put code inside of the devices to upload violations of use.
They did?
Yeah, that's what they're doing against the regulators. So that's why they can eliminate their requests.
Oh.
Because you're violating your use agreement.
So now they're getting problems from multiple fronts. So it'll be very interesting to see how they're gonna get out of this one. Okay, I'm gonna update one more time. This one is the x86 Atom 64 image. So we'll do another update. And if you have your thumb drive with you, or if you have your drive with you, do all the updates here because it's just a whole lot faster than most of us when we get home.
I'm updating on my phone.
Yeah, my home one's not that much slower than here.
Really?
Yeah.
Over here, it can go as fast as I have seen,
Oh yeah.
like 10 megabytes per second.
Yeah, it just goes.
All right. So now we got everything here, and we're gonna import this new project, which is called Socket 1. Here we go.
Really, we weren't gonna go with socket 2 me.
There'll be a Socket 2, of course. Yeah, this one took me a long time. I spent the entire weekend working on this one, and I thought it's not going to be that big of a deal because I know sockets already. I know the basic operating system concept. I have written code from the server side. Okay, this is just client side. How hard can it be, right? Yeah, famous last words. Yep, famous last words. And then I still have issues with the tool itself. Okay, the debugger doesn't seem to work. So that kind of adds to the whole delay. Okay. All right. So at least we got the app going. And the first thing is I'm going to run the app first. Okay, because I just want to show you guys, what it does, and then we'll go back and explain how it does it. Okay. So here's main activity, which doesn't really have a lot of new things. It had some, but most of the logic is in simple TCP model. And we'll let Gradle finish its work, and then we'll go ahead and run it in the simulator. But for some reason, I'm hoping it's not a universal issue, but for some reason, I can't, when the app crashes, all those, Java, messages do not get displayed in Android Studio anymore with this new version. At least with my home computer. I haven't tried this one yet. So hopefully that's not a universal problem, so that we won't have that problem here. So the main topic of today is to talk about a socket, or network sockets in general. It's going to be beneficial to those people who want to open up a general socket to a particular port on the computer that is somewhere in the cloud. Okay, so this is going to be useful for those people. If you specifically just want to open an HTTP connection to a website, it's easier. Okay, but some of the stuff that we talked about here would still be useful. All right, so we'll go ahead and run this in the emulator. So there we go. Get it started. Yep, that's it. From the power server, the home page of the power server. That's the easiest way to kind of, check that it works. Because it's a resource that's already out there, and it's HTTP, plain text, so it's easy to figure out how to do it. Right. And it's building the APK, uploading. Okay, so there we go. We have this app up and running. And obviously, the only thing you're supposed to do is click the start button. And after you click the start button, it will download something, and it's an HTML document. Okay, so what you see here is just an HTML document, which doesn't seem to be a big deal because if you're on a general computer, you can use Telnet to get this done. So I'll show you guys how to use Telnet which is a program that most people say do not use because it's a big security flaw. Well, as long as you don't use Telnet to log in to a shell, okay, and pass any passwords, it's okay. Telnet is an extremely useful tool because you can do something like this. With Telnet, you can tell it where you're connecting to. So in this case, I'm connecting it to the Power server, just power.arc.losreals.edu. If you know the IP address, you can also supply just the IP address. But this is the other thing that some people do not know that Telnet can do. You can specify which port number you want to connect to. Because in most cases, people just connect to the default port number, the Telnet port number, which I cannot remember. Is it 23 or 25, one of those low numbers? But if you don't supply the 80, it is connecting to the Telnet port, and most servers today should have that port closed because it's not secure. But you can also specify 80. So when you connect to port 80, which is, oh, okay, I guess I don't have it installed here. So let's go ahead and get it installed because I do want to show you how this works. Aptitude install Telnet. It's a tiny little program, it shouldn't take long. There we go. Okay.
Almost as long as clean W. I said almost as long as clean W.
Clean W.
Yeah, we ran it last week.
Oh.
Like installed all this stuff to delete the build.
Okay, there we go. So we can now repeat the command. There we go. So now we have a connection open through port 80 to power.arc.losreals.edu. HTTP is for the most part a plain text protocol. In other words, you can just type get with an enter key, and it will get you the HTML document. This is the home page. Okay, so it's a very easy way to check whether a network connection is working or not. Okay, you have to supply the host name or the IP address, the port number, and then once you have the connection, you supply the command, and then it will return back whatever the response is. And because everything is plain text in this case, it's easy to issue the command. It's also easy to get the document back. So in this case, I can actually do something like this. I can do it through less and show you, okay, so after you get all the connection done, this is the document you should be seeing. Okay. That is strange. It's not. Okay. Fine, we'll capture it to a file first. There we go. Okay, so this is the actual, not counting the first 3 lines. This is the document that is that is the response of the get command going to port 80 of power.losreals.edu. So when you compare this content with what is displayed in the app, now it's pretty hard for you guys to see this on the screen, but it is the same thing. HTML, head, and then we have a link, and then we have a href of style sheet version 2.css, and so on. In other words, the app is not doing anything more than just doing a telnet get and display the content on the screen. Okay, but it is showing you how to use a socket. How do you open a connection to a server on the internet in general, and how do you get content out of that server? So that's the focus of today's class. So right away, I'm going to tell you one of the stupid mistakes that I made in the app. So instead of using, okay, let me show you how to do this by hand first. There we go. So in the app, I just said, get as the command, and of course nothing happened because it's waiting for the enter key or the line feed character to say that, are you done with typing your command? And I forgot about that. Now, when you're using Telnet, it's kind of obvious because, in most cases, when you type a command, you press the enter key in order for the command to be executed. But you do it in the app, you go like, how come there's no response back? And then you start to doubt other things that might be going wrong. So in this case, it's just because I did not press the enter key, which is the line feed character in the app, and that's causing the problem. Okay, so switching back to the app here. This is main activity, which is one of the main files, but we also have a program called, a Java class called simple TCP model. And simple TCP model is actually handling the most part of the logic related to a network connection, which is assumed in this case to be alternating between a command, a response, another command, another response, and so on. Now, a TCP connection doesn't have to be like that. A TCP connection is what they call a stream-based connection, which means once you open a connection to a server, in general, whatever traffic is going to the server and whatever traffic is coming back from the server, they can be completely asynchronous. It's not necessarily command response. It can be, you can be spewing some stuff to the server, and then the server is continuously spewing something back to you. It is entirely up to the protocol and also the programs to decide how they want to shape the traffic. But in this case, it is a very simplistic model, which is based on, okay, you send a command, you expect a response, you send another command, you can expect another response. So we'll go ahead and take a look at main activity first, and we'll say, okay, so what happens when I click the start button on the screen? So what you need to do is to locate that code first, okay, which is in onCreate. In onCreate, we have some kind of additional stuff to remember, what is this activity, and then we have a handler. Okay, so can anyone remind me what is a handler, and how do we use a handler object? And in this case, my handler is one of the members of this particular class. I just added that to the class. But what do we do with a handler? What does it do?
Delegate the task that is being triggered by some other event elsewhere.
Okay, and it has to do with it's necessary when you're dealing when your program is structured in a particular way. So when do you need the concept of a handler?
You want to push something to the UI.
When you want to display something in the UI, but generally speaking, if you have a single thread program, you can deal with the UI anywhere you want to. So this is necessary only if you have a background service or
an event process,
a multi-threaded program. Okay, so you guys are pretty close. Okay, because all of those concepts are related. But in this case, anytime you have a multi-threading process and multi-threading app, and one of the non-main/UI thread wants to update the screen, that will need a handler. Now, how do you know? Okay, so the whole purpose of a handler is for a thread that is not the UI or the main thread to know where to send a message or how to post an action. Okay? So the question now is, how does it know which thread we are talking about here? So as it turns out, whoever is creating the handler object, whoever is calling the new and calling the constructor, is where the object is associated with. Okay, so in this case, whoever is calling onCreate, whatever thread is calling onCreate, the onCreate method, is the one that is going to be associated with the object referenced by my handler, which is exactly what we want, because onCreate is called by the UI thread, because this is before we actually get a chance to create our own threads. So this is guaranteed to be called from the main thread, and that's exactly when we want to create the handler object, which includes a pointer, a reference to the message queue of this particular thread. So any other objects, any thread that can get a hold of my handler will now have a means to send a message to the UI thread and say, hey, I want you to do this for me. Is that okay so far? Okay, all right. And we'll also create a TCP model object, out of the simple TCP model. And the use of this is going to be done later on. And this is how, okay, I'm just going to expand this code here. This is a typical way to look up and find out where the button is. And when you're dealing with a button or any view, you can set up a on-click listener. And this is nothing new either. We are using the interface on-click listener to create a anonymous class in this case. And the anonymous class only needs to have one single method. It can have additional stuff too, but this is required. It must supply a on-click method that is public to tell us what to do when the button is clicked. Okay. So when the button is clicked, we're doing two things. One is we register state change listener to this activity, and this activity is a member that is a part of main activity that's initialized by this time. And also we are going to call another method, on server specified, and then we basically specify the name of the server and turn it into a string, and also pass the port number as 80. And this is going to start the whole process. It's going to start the whole process of, okay, we are going to make a connection to power.arc.lostreals.edu at port 80. And so after the connection, what are we going to do? Right? Okay, so there will be some kind of interaction between main activity and also TCP model itself, or whatever object is referred to by TCP model. Are we doing okay so far with this? So we're giving it a kickstart and say, okay, let's start with making a connection to the power server at port 80. Okay. So now we want to switch our view into simple TCP model. And in simple TCP model, we have a few miscellaneous definitions. One is an interface definition, so that your main activity is actually implementing this interface. We are defining a few private, a few members of this particular class. Just like before with the MVA discussion, we are keeping track of a list of listeners, not just one, but a list of listeners. So this is a list of on-state change listeners. An on-state change listener is the interface that is defined right above the line that it has the blinky cursor. In other words, we can have multiple listeners, okay? When we get something from the server, when there's some kind of state change, we can let all of those things know that there's a state change, not just one. So just in case you need to let multiple objects know that the networking part of this particular object has a state change, they can all get notified. We're not limiting it to only one. Is that part okay? Just like the MVA model then. Okay, the MVA program has exactly the same setup.
But that's only necessary if we need it, right? Other than that, we could just keep a single listener.
You can only, yeah, exactly. You can have a single member, which is of the type on state change listener. That would it will work with this particular program. But when you do want to have multiple components of your app to know that, oh, okay, we are getting stuck or we're getting more traffic, then this will allow you to do that.
Could we just put a wrapper around it? It's
a
single listener, but it has a list of listeners.
You can put an adapter. You can put a broadcast adapter to it. So the adapter itself talks to this, and then the other end of the adapter can have multiple listeners. So you can stack it like that. Yep. We have a member called exception. I don't have any use for this just yet, but it might come in handy later, because a lot of the operations that we're doing with this particular class can generate an IO exception. Okay. So instead of catching the exception and then not do a single thing about it, or just to pass it along, I want to save the exception and not to pass the exception along. So that's something that you might want to think about is, do you want to process the exception and just stop the exception at this point in this particular class, or do you want to rethrow the exception so that whoever is utilizing this class will also, or whatever is calling the method that can generate an IO exception, will actually get the IO exception. Okay, so that's up to you too. There are pluses and minuses in each approach. You just kind of have to balance and go like, okay, which one makes more sense in this case. This is one of the main classes that is useful when you are dealing with a client socket. It's not socket itself, it is socket channel. Okay, so there's a main difference between a socket, which is a class name, as opposed to socket channel, which is another class name. If you just want plain blocking calls when you're interfacing with a network connection, a socket can do it. But a socket will only let you do that, but a socket has one added advantage of giving you an input stream as well as an output stream. So it gives you better abstraction. Okay?
The socket channel has that?
A socket channel does not have that.
Oh, okay.
So a socket channel has a much lower level interface where it will give you, a very basic read and write operation, but it's not quite as a stream either. So it doesn't give you the input stream nor the output stream like a socket can, but it gives you more control over it because this is a lower level construct. So with a socket channel, you can set up the read, write, connect, and many other calls to be blocking or non-blocking. So it gives you that option. As opposed to a socket, which doesn't give you control over the blocking aspect of whether a read-write operation is going to be blocking or not. So we'll get to those when we get to the actual read-write operations, because that's one major difference between a socket as opposed to a socket channel. I need this to be remembered, the server address to be remembered as a member of the class itself, because it needs to be accessed by a thread that needs to get to this, after the call itself is gone. And we also have a string to remember what is the current request, which in this particular sample program is just GET and then the line feed character. That's the actual server command or server request. We have a byte buffer called BB. Okay. All right. So let's skip the utility function state change, and then we'll go to the enumerated type called states. Okay. So the enumerated type states is basically defining all the distinct states within the state machine. How many people still remember the discussion of a state machine, or in the UML they call it a state diagram? Do you guys still kind of remember that? No? Sort of? Okay. Yeah. Okay, we have a kind of quick description of what is a state diagram. I did not give you guys a picture, but I did kind of talk about it a little bit in class. Okay. So this is actually one of the main topics of today's lecture as well, is how do you look at something to be done as a state machine? Because when you look at something as a state machine, it really helps you design your class as well. It helps you kind of identify how it will interface to outside the class. What kind of methods do you need to supply? How do you trigger operations for this particular object? And when this object needs to notify somebody and say, okay, we have, I have a state change, then you have to, it will help you define what kind of interface is appropriate for notifying other things outside of the object, and say that, okay, something in me has changed. Okay, so we'll deal with this later. As an enum, all of these things are really just integers, except the constants representing all of these constants are not automatically handled by the Java compiler. So you don't have to say, okay, the first one is 0, the second one is 1. We'll let the Java compiler determine those values. And I think unlike in C++, enums cannot be seen as integers in Java, which is actually a good thing, because then people cannot try to hack it. Okay, so we have one single member called state to remember what is the current state of this particular object. And then the constructor is just this. Constructor says, we are in the initial state. We are going to initialize listeners so that it becomes an actual instance of a linked list. The linked list is going to be empty to begin with, and everything in the linked list, each thing is an on-state change listener. So we have basically nobody by default is listening to this particular object until we register something. And the registration is just done by this call here. We're just adding whatever the parameter is to the linked list called listeners. Yes?
So in that case, it's just saying state equals 0? Is that what you're saying?
Yeah, basically it is just, or whatever constant is associated with initial state.
So you just wanted to have them friendly names instead of...
Exactly.
Okay.
Instead of using, actual literal constants where I would start to lose track, I cannot remember whether 3 or 4 is, for instance, weight connection. And if I use the wrong one, that will have bad consequences. But in this case, if it's all spelled out, I can see, okay, we're in this state or so on. All right, so this is a try block, okay? Try and then a catch, which means whatever I do in here can potentially end up with an exception. So this is the operation that can end up with an exception. Socket channel dot open can potentially end up with an exception. And the exception is not only limited to an I/O exception, but I think it is mostly an I/O exception. You can look up the open call of a socket channel and know what exceptions it can throw. So I spend a lot of time getting stuck at this point. Okay, right off the bat. Okay, just creating the object itself. I've not even specified where I want to connect to. So this really should have no dependency on networking whatsoever, because I'm just saying, give me a socket. And this is just a socket. It's basically just going to Home Depot, okay, and you buy one of those little sockets, you put it into your bag, and then you go home. Okay, so even if I'm not a licensed electrician, I should still be able to buy it, right? You would think that is the case, but that's not actually the case. So in order to do anything like this, to actually have any type of potentially network related activity, you have to have the permissions. Even if you're not actually connecting to a particular server, just by saying, I want to have a socket channel object, you need to have the permissions set correctly. So that's the first point where I got stuck. Is like, how come it's always returning a null? Okay, well, I looked up the Java documents. The Java documents obviously is not gonna help, because Java documents in general is designed for general Java applications which can run on a PC, on a server, okay, and so on. So typically, they just say, okay, you can go ahead and have access to the network. But this is an Android app. So with an Android app, that permission is not by default turned on. So the first thing I actually had to do is to go to the Android manifest file and added, not all 3 are needed. I think access Wi-Fi state is not actually needed, but these 2 are. So you have to add these 2 permissions. One is called access network state, and I think that's the one that is actually needed by socket channel open. And then the other one is to have internet connection or internet permission. So if I take these 2 out, then the exception would be thrown, and I would end up with a null reference, and there's no object that I can use to play with. So that was one problem. And then the second problem was when I have a null reference, for whatever strange reason, Android Studio did not give me the error message that it usually would. Like it would say, oh, you have a reference to a null object online, blah, blah, blah. Eventually it will report that. But the new Android Studio 2.3, for some reason, it could be a configuration issue, but it's not reporting that. So I was having a really hard time trying to find out why is my program crashing? And it just crashes out without giving me any indication of why or where it crashed out. Yeah, that kind of reminded me of the good old days of embedded system programming, where I had to use a single LED to debug a program. Did I get there? But since I have a debugger, it's a little bit more helpful. Okay, so but this is really kind of interesting, because when you use this tool, by the time you type uses permission or just uses, it will let you select the uses permission. And once you do that, it will give you a list of permissions that you can choose from. So it's kind of nifty, from this sense, that you don't have to remember all the names of all the different permissions. You can just kind of pick from this list. Okay, so let's say I want to know battery stats. Okay, And then once we have the permission here, the moment you type the slash to end this element, it automatically ends with the angle bracket as well. So it's kind of cool. But we do not actually need this one. I'm just using it as an example. So there we go. So this turned out to be one of the things that you have to do if you want to even open the socket channel. Without specifying where you're going to, you still need these permissions. The last one is not needed. Wi-Fi state is not needed. So we can take this out.
You only needed internet because you went out.
Sorry?
You only need internet because you went out.
I think network state is
So
needed as well.
if you were still on 127,
Yeah, network
you
state.
could probably get away with
Wi-Fi
that.
state you don't need to.
True.
Unless your thing depends, is checking to see, oh, are we on mobile or are we on?
Well, network state for sure is needed for socket channel open. Because socket channel open is just saying, give me a socket. I'm not even connecting it yet to anything. So if that is failing, it's probably not because of the internet permission missing. It's probably because just network state is missing.
You can't touch the network.
Yeah, but I'm just buying a socket. I'm not even hooking up to anything.
It's more like a hose, though, isn't it? More like a hose.
A hose?
Yeah. I went to Home Depot and you bought a hose. I want a hose, please. Give me a hose. It's got two ends.
I have a suspicion, before you even make a connection, there are some hidden operations when you do a connection, because just by saying open, it might require you to bind it to a local port and a local IP already. I think that is why it is not letting me do it.
You have to bind the socket to a port, then you can ask that port
A
to
local
connect
port,
across, yeah.
a local port, and that is probably why it needs access to network state. So that's my suspicion. But anyway, I had to look around and find out, oh, okay, I need permissions to do that. So that's one thing that took a little bit of time, and the debugger not working. The debugger was working, but it's not reporting problems when the program crashed. That actually was taking up a lot of time. So having the exceptions actually reported when you run the program is really helpful. So anyway, if I do get through the open without generating an exception, then I'm going to turn the states into an idle state. Otherwise, if I get to the exception here, I'm going to end up in the error state, and probably a good idea to remember what the error was or what the exception is, so I can remember the exception in my own local member. So this way, if I need to look it up ever, okay, what went wrong, I can always go back to exception as a member of this class, because the message is in there too. So even if you're not reporting this in any way, just by using a debugger, stop it, examine the object, you can figure out what went wrong. And that's exactly how I figure out that I was missing the permission. Okay, are there any questions about the constructor itself? This is the constructor. Okay. And then set timeout, I'm not going to talk about it because I'm not using it just yet. All right, so this is on server specified, which probably should just be called, specified server or something like that. This is the subroutine or the method that allows the caller to specify where do you want to connect to and through which port. So you can supply a string as the server name. In this case, it's power.arc.losgrios.edu, and specify a port number, which is port 80. So without really going into IP, or TCP IP, and then UDP as well, when you specify a connection point in IP networking, you have to supply two items. Well, I shouldn't say IP, it's TCP and UDP communication. You have to specify two things. One is the IP address or the server name of whatever machine you're connecting to, but eventually the server name is converted by looking up a DNS server and turned into an IP address. So eventually this is all going to be IP address based, but you can always specify just the server name, and then the system can do the conversion using a DNS lookup. The port number is also important because to the same IP address, there are 65,536 ports. Okay, and each port has a special purpose. In other words, if you guys are used to it, port 80 is usually for HTTP. How about 443?
Yes.
HTTPS or HTTP through SSL. Port 22,
Secure,
SSH, secure shell, and so on. Okay, so there are certain known ports for certain things. It doesn't mean that you cannot remap the ports. It's just that if you do remap the ports, then your clients will have a hard time finding, okay, which port am I supposed to connect to? Okay, all right. So the first thing I do is I'm checking whether I'm in the idle state or not. In other words, you only want to serve this particular request as a way to make a transition if you're already in the idle state. If you're in some other states, I'm just not going to do a single thing. So the result local variable is initialized to be false. So if I don't do a single thing, if the current state is not the idle state, I'll simply return false as a result and say, nope, I did not do a single thing because this is not the right, I'm not in the right state to handle specifying a server, a connection point. Is that okay? Is that logic okay? So it's basically I'm using this as a guard condition and say that if I'm not in the right state, I'm not going to process the rest. So the rest here, this is the other sticking point. The other sticking point is I have to relax the thread policy to allow all. Okay, to basically allow everything that the application is allowed to begin with. I found that without these two lines, the program would not work either. So I would have another exception thrown when I try to make a connection right here. So that's the other thing that we have to remember to do is to change the straight mode policy to allow this particular thread access to all the permitted things in the entire application. I have to look this up a little bit more, but I did locate this particular thing, and it was effective. It did fix the problem that I had earlier.
Did you try pitching a runnable to the handler?
The handler is right here. The handler is not even here, but it is called implicitly from a state change. So anytime you call a state change, it can potentially go back to the handler.
But you're already in the thread when you say socket channel connect. I was wondering if you tried to pitch that to a handler. Give it back to the real thread, because you're in a separate thread.
This is not in a separate thread yet.
Not yet?
But it can be called in a separate thread. But it can also be called, but this one is actually called in the
Looks like
UI
you just
thread.
created a new thread in helper thread and you just started it, and it's that thread that connects on the socket channel. Right there at line 103.
Oh, you mean this one here?
Yeah.
Yes, it is the helper thread that makes the connection, and there's a reason why I use a different thread and do it in a separate thread. Okay? All right, so this part is not done in a separate thread. This part is just initializing the server address. So the server address is a particular type using the type inet server socket address, and is made out of either both the server name and the port number. And I have to remember this object as a member of this particular class because it is needed over here, which is in a separate thread. Okay? All right, so this is the part where it starts to get a little bit confusing, because this is helper thread is nothing more than a local variable of this method, and it is initialized to a thread object. But the thread object, when you initialize, or the constructor of a thread object can take on a runnable, and the runnable is basically the interface of an object that consists of at least the run method that returns a void, and it has to be public. Is that okay? Basically, I'm creating a new thread, and whatever I specify in the run method is what the thread is supposed to do. Okay? But just by passing the object, just by remembering the object, it's not going to run anything. The thread will only start execution when I have the helper thread .start. Okay, so this method call will basically say, okay, this thread is now active. Go ahead and schedule that at your convenience operating system. So it is still dependent on the operating system as to when this thread will actually start to do its thing. So you have no control over, is it starting right away before result gets true, or is it going to start until this thread has some time, or until it gets back to the main loop? We have no idea. It's up to the operating system to do that scheduling. Okay, so what are we doing inside this particular thread? This is what we're doing inside that particular thread. The first thing we do is we initialize a local variable to false. Okay, connection made is initialized to false because I want to know, did we actually make a connection? Even though an exception may not be thrown, we may not be making a connection. And right before we do the socket channel connect, which is this call here, it has to be done, first of all, it has to be done inside a try block because it can throw an IO exception. So I have to do it inside a try block. But before we actually make that call, I basically remember my current state to be wait connection. So that anything that's trying to query this particular object can know what it is currently doing. I'm waiting for a connection. Okay, and then we make this call. Now this call, to connect can be blocking. It can also be non-blocking. When it is a blocking call, it simply means that until the connection is established, this call does not return. So now the question is, how long would it take? How long does it take to make a quote-unquote connection to a remote server? Okay. So if I were to illustrate it using the command line, it's basically asking this question. After I type get and press the enter key, how much time, well, actually I take it back. How much time do I need between pressing the enter key here on the command line and the time that I actually get into this part here where it's waiting for me to type something? Now to you, how much time did it take? It's almost no time, right? Okay. Because one, the power server is local to this campus, so the network traffic or the number of hops it has to go through is minimal. Two, the power server actually doesn't have a whole lot of traffic or activity right now at this point. So it doesn't take much time to make that connection. But what if this is going through a lot of hops? And some of those hops are residential, or there are bottlenecks. It can take longer just because of network lag itself. And then two, what if the server is really busy? It might take half a second, okay, for instance, to actually have the connection made. In other words, the time between I type enter to this command and the time that I get to the prompt to type something to the server, that might be a fraction of a second, half a second. Now, half a second to us is not a big deal, right? I mean, if you have to wait half a second on the command line program, we just look at this and go like, well, as long as it's not like multiple seconds, it's still considered acceptable. But if you do this inside the UI thread, what is going to happen to your user interface?
It's going to lock up.
Yep, it will be a lockup. Okay, there will be half a second where nothing can happen in your user interface. If you have a clock update, you have any type of animation on your screen, anything like that, they will all be frozen for half a second. That may not be the best thing you want to do, okay? So that's why, in general, when you are going to make a call to a blocking method, including a connect with a socket channel, you don't want to do it in the UI thread. Or if you want to do it in the UI thread, you have to make it a non-blocking call. I'm not even sure whether connect can be non-blocking because it doesn't make sense to me that it can be non-blocking. Well, maybe it can, yep.
So when you see an app that's using like an update screen, that's kind of how they're doing it. They're using another thread.
Yep.
One to do the actual imaging and then one to do the updating.
Correct. In other words, whatever so this is the bottom line, okay? When you're talking about the main/UI thread, everything that it has to do has to be quick. Okay, it has to be a quick thing that you can update on the screen, quick calculation or whatnot. Anything that can potentially take a longer amount of time, you want to spin off another thread to do it. Okay, you're good. So I'm just going to look up the Google or Android documentation just to be sure that the connect call is always blocking. So this is how you can look it up. You look up socket channel Android. It is a Java concept too, so you can look up the Java documentation instead of Android documentation. And the call that we are concerned about is connect. So you look up the document, look up the connect call, and then you try to find out whether it is always a blocking call or not. Okay, if this channel is in non-blocking mode, then an invocation of this method initiates a non-blocking connection operation. So it is not always a blocking call. So when it is not blocking, it will return right away. But it returns right away, you can almost be guaranteed that the Boolean, the result, is going to be false because it has not made that connection yet. You have just initiated the operation to have a connection, but it's not done yet. So it's always going to be returning false in that case. If the connection is established immediately, as can happen with a local connection, then this method returns true. Otherwise, this method returns false, and the connection operation must later on be finished or completed by invoking the finish connect method. So a non-blocking connection operation is initiated by placing a socket channel in non-blocking mode and then invoking its connect method, which is what we just talked about. When the connection is established or attempt has failed, the socket channel will become connectable, and this method may be invoked to complete the connection sequence. If the connection operation fails when invoking this method, it will cause an appropriate I/O exception to be thrown. So if you're doing it not in non-blocking mode, then you have to call this subroutine to finish it. If this channel is already connected, then this method will not block and will immediately return true. If this channel is in non-blocking mode, then this method will return false if the connection process is not yet complete. In other words, it will let you check whether it is done or not. So the checking itself is really fast, but then the problem is, how often are you going to check? Okay, so if you only have one single thread, if you only have the UI thread, then you have to use this particular method in non-blocking mode, because you're just going to go back, you're going back to basically periodically poll and ask, okay, is the connection done? Nope, okay, I'll come back later on and check again. But in the code that I have in Android Studio, I am actually using the blocking mode. In other words, this is not going to return until it is either done, okay, the connection is actually made, or it is, it cannot be made, in which case the I/O exception is going to be thrown. So this is a good time to talk about non-blocking versus blocking calls. If you have a choice, which one are you going to use, and how do you use blocking versus non-blocking calls? What do you think?
Blocking.
Okay.
Well, it depends.
It depends. Okay, very good. It depends.
If you're ready for the challenge, non-blocking is fine.
Okay, if you can spin off multiple threads easily, and the threads are not costly, by the way. So if you can have multi-threading, not blocking calls make more sense, because your logic will be more sequential. It's easier to follow the logic. With non-blocking calls, then your logic will get, 1, more fragmented, 2, more complicated. But it is the only way to do it if you can only have one single thread. Yep.
Wouldn't the non-blocking be a little bit more overhead too? Because you have to be pulling it with to see if it's ready.
It depends on whether it is actually a polling kind of thing or not. But yes. It's this is also the main difference between a socket as opposed to a socket channel. Okay, so I'm going to go back to the documentation of a socket channel here, and one of the things that they talk about, where most people would just go like, okay, yeah, it's called selectable. What does it mean when they say it is selectable? I'm not expecting anyone in this class to actually know the actual technical definition of what is quote-unquote selectable from the perspective of the operating system.
You can use an FD selector.
Hmm?
You can use an FD select.
You can use the FD select. Very good. Okay, so we do have a winner. Thank you. But what does that do?
allows you to have a blocking thread waiting for all those sockets.
Yep.
And then know
or
which
file,
socket.
whatever file descriptor. Whatever
and
file
then know
descriptor.
which one was active.
Yep, exactly. So the word selectable, turns out to be very, has a very specific meaning, okay? It relates to a Linux, or generally speaking, operating system kernel concept of the select call. Okay, so if you look up the select Linux man page, okay, that should find it. There we go. So selectable eventually links to the select call. And the select call is, has a, okay, let me magnify this a little bit here. Okay, so the select call, has a prototype like this, okay, which looks really kind of awkward. It has got NFDs, or number of file descriptors. It has a particular set for read operations, a particular set of write operations, a particular set of exception file descriptors, and also a timeout interval. Okay, so what you do with a select call is you set up a set. Okay, I'm not going to talk about how to make or generate a set. Okay, the next 4 macros, or the next 4 functions, basically one for clearing a file descriptor from a set, one is for checking whether a file descriptor is set or not. This is checking whether, this is actually setting a file descriptor, and this is for zeroing a particular file, zeroing the entire file descriptor set. So they correspond to set theory. Okay, you're checking whether an element is in the set. You are clearing or removing a particular element. You are also, adding an element into the set. So that's what those particular things are for. But this goes even deeper into the internal representation of what a file is. A file can be a socket. A file can be standard in, standard out. A file can be a regular file that is living on the file system with a name, folder, and all that. Okay? But every single file that you open, every single file that you want to access from the program is actually only represented by an integer called a file descriptor. So that's what this FD is for. FD stands for file descriptor, which is no more than just an integer. Okay? So in other words, what the read FDS is a bit field. Okay, it's basically just an integer, an array of integers, and each bit is representing a particular file descriptor. And what you do is you are setting a 1 corresponding to the file descriptor that you want to say, hey, if something is ready to read, let me know. Okay. So of all the file descriptors that you have to deal with in your program, you can set these 3 sets accordingly. This is the first one for all the read operations, for all the write operations, and except, is it exception or, okay, let me just find that word. Yep, that's for exceptions, and I'm suspecting a connection is going to fall into this part here. So when the connection is made, it's going to, if you specify that file descriptor here, it's going to come back and say, okay.
Then you get a read one. I think you get a read one.
You get a read one? So
It's
after
reading and writing, but it's not an accept state.
It's not accept?
Yeah,
okay.
that's a bad state.
Exception is a bad state, so the file is broken.
Pretty sure.
Okay. But selectable basically means, in this case, it is something that can be done using a low-level select call. So getting back to the higher level description of a socket channel, this is the main difference, because when you use the socket class, it doesn't say anything about selectable. The socket class gives you a high-level abstraction. It gives you an input stream, an output stream, and say, okay, go have fun with it. But it doesn't let you say, okay, I want it to be blocking or non-blocking. Is that okay so far? Sort of? Okay. So all of these are kind of important operating system concepts, but I don't think they teach this stuff in any one of our classes here. The only class that used to teach select is CISP 457, and that's only because I was teaching it. But these are all important operating system concepts. But getting back to this program, I am not using the blocking mode of operation. So this call here to connect will actually block until it either makes the connection or until the networking part of the operating system reports a problem, in which case it will throw an exception. All right, so if it does throw an exception, I'm going to remember what the exception was, okay, remembering that as my own member, and I'm going to throw the state of this particular object into the error state, okay, so this way, anyone who's probing, would know that. And after the try catch block, if the state is not the error state, which means it didn't go through the exception, then I will check connection made, which is a local variable, to remember whether the connection was actually made or not. If it is made, then I'm going to state change to now we have a connection open. Otherwise, it will also go back to the error state. I do not think this branch is possible, because if the connection cannot be made, I think an exception would be thrown. But just to catch all the possible cases, I'm just saying, okay, if the state is not the error state, but the connection was not made, I still want to end up in the error state. So this would be a good time to go check out, okay, but what is state change actually doing as a subroutine, as a method? So when you look up state change, it is all the way up here. So state change only takes one parameter, which is, okay, what is the new state? So the way it does it is it would use a local variable to remember the current or the old state, quote unquote old state. Then it would change the state of the object to the new state. And then it would use an iterator to go through every single listener of this particular object and say, oh, by the way, I have just made a change of my state from the old state to the new state. Is that okay? So this is what allows a listener to basically say, oh, by the way, when the connection is made, let me know. I might want to do certain things, when the connection is made. Is that okay? So this is also a good time to link back into main activity and see, okay, so how do we make use of that? So in main activity, there are two things that we need to look at first. The first one is main activity implements the on-state change listener of simple TCP model, which is the interface that we talked about a little bit earlier, which basically means it needs to have a method called on-state change. It has to return a void, and it has to be public. And there are two parameters to it. The first one is the old state. The transition was from this state to the new state. So now main activity has a point where it can say, oh, okay, so when the network operation has an answer with a state change, I can respond to that. I can say, okay, at this point do this, at this point do this, at this point do this. And I use a switch statement to look at this, to examine what is new state. And for the most part, old state may not be useful, but it may be useful in certain situations. So it is passed as a parameter, but none of my cases need to know what was the old state. So if I know that we are transitioning to a new state, and the new state is the connection is already open, then I go, good, now that we have a connection open, let's go ahead and send this request, get with a \n, which is a line feed character. Does it make sense? So now we have a interaction between the main activity class and the simple TCP model class. The simple TCP model class simply says, okay, now we have a connection open, but I have no idea what to do when the connection is open. It is up to the listener, in this case, to say, oh, okay, now that the connection is open, I want you to do this. This is the command that I want you to send to the server. Okay? All right. But by doing this, by calling on get new request of TCP model, which is over down here, it is going to, this is the method being called by here. So line 34 of main activity is going to end up on line 127 in simple TCP model. So it will first check whether the current state is in fact connection open or not, and if it is, then it's going to make a request. So to make the request, I have another helper thread, and this particular helper thread would perform these operations, quote unquote, in the background. Okay, so this is where we need to have a byte buffer. BB is a byte buffer. It is also a member of the class. To use a byte buffer, the first thing you need to do is to allocate based on how many bytes you're going to need in that thing. And B itself is initialized to be current request get bytes, and current request itself is a string. Okay, so this will basically return the number of bytes that we need in order to represent the request itself. And by doing that, we can now use the length of B, which is an array of bytes, to tell us how many bytes we need to allocate with a byte buffer. And then we're going to put all those bytes in B, which is an array of bytes, into the byte buffer. Are we still doing okay so far with this? Okay. And remaining count turns out not to be necessary, so we don't actually need to keep track of remaining count, because a byte buffer automatically takes care of that, which is nice. All right, so we have a try block here. By the time we get to the try block, we have already set up the buffer, which is basically containing the command or the request itself, and say, okay, this is what we need to transmit to the server. The try block is the one that is actually attempting to do it. The only part here that needs a try and a catch is this particular call here. When you write to a channel, you have to supply either a single byte buffer, or you have to supply an array of byte buffers. In this case, we only have one single one, so BB becomes the only parameter to the write call. And what write would do is by interacting with BB or a byte buffer, it can actually self-maintain, okay, we got 4 bytes to transmit, how many bytes is left to transmit? And that's why we have the condition being task remaining. In other words, if this were a non-blocking call, it would just send whatever is that it can actually send through the network. So if the network layer says, oh, we can only send 2 bytes at a time, then it will only send 2 bytes. But then in that case, BB has remaining will be true because it has 4 bytes to transmit. After transmitting only 2 bytes, then has remaining will still be true because we have 2 more bytes to transmit. So the structure of this loop here is to account for the case when write itself is a non-blocking call. So it will still be able to handle that. Now, of course, if write is a non-blocking call, this becomes a busy waiting loop, which is probably not desirable either. But if it is a blocking call, then the way I set up BB is it should only take 1 try to write everything that I need. But just in case it does not, it will still be able to handle that. But the way of the structure of this loop is set up for a blocking call, because otherwise it becomes a busy wait, which is not desirable. Is that okay? If you want to turn a write into a non-blocking call, then you have to either use a select to basically say, okay, when there's room in this particular channel, wake me up. So you need to have some way to block and say that, okay, this thread is going to sleep until something happens. Or you have to do polling. Come back and say, okay, do we still have more to transmit? Yes. Okay, now go ahead and try to transmit as much as you can, and then check again later on to see how much more you have to transmit. Are we doing okay so far with this code? So the way it is right now is it is completely set up for blocking calls and not for non-blocking calls. When I get out of this loop, which basically means BB does not have any remaining bytes to transmit anymore, then I change the state to wait response. In other words, this is for a very simple model of you transmit a request, you wait for the response, you transmit another request, you wait for another response. This is not in for the cases where you can simultaneously transmit a new request while you're still getting the response of a previous request. Okay. And that's why the class name is called Simple TCP Model, because it doesn't handle asynchronous request and responses. All right. So this try block has a catch block here. The catch block is going to remember what the exception was and then make a state change to error state, which will also let, in this case, main activity know that, oh, we have a problem, and then main activity can turn the whole screen red if it wants to. Okay. So after the try catch block, we have a check here to see whether we did end up with an error state or not, because because I caught the exception, which means the exception is not being passed along. If I did not end up with an error state, then the current state has to be a wait response. So by the time we get to this statement here, it means the response is, the request is now sent, and we are now in the state of waiting for a response. So the first thing we do is I am just reusing BB, which is probably a bad idea because right now BB only has a capacity of 4 bytes. In other words, I'm setting up the rest of the logic here and say I can only read 4 bytes back with each read operation. So that's going to generate a lot of overhead because if you have a really big response coming back, something that is in the order of, let's say, 20 kilobytes, it would take a lot of iterations to get those 20 kilobytes when you can only read 4 bytes at a time. Okay, so if you want your algorithm to be more efficient, you can reallocate for BB. Just go ahead and call byte buffer.allocate again, and this time use some number that is reasonable. Okay, 1024 bytes. Okay, whatever amount you feel is reasonable for your case. But this will still work. Even with a buffer of only 4 bytes, it will still work. It would just take a lot more iterations to get it done. So now that we are ready to read the response back from the server, I would be stuck in the loop. And the reason why this is also in a try-catch block is because of this operation. The read method of a socket channel can throw an I/O exception. So that's the reason why we're in the try block. So I'm getting stuck in the loop as long as the return value is greater than 0 for this read method. When you read the documentation of the read method of a socket channel, it basically has 3 possible cases. It can return a greater than 0 value when it read that number of bytes. So in other words, if read return value turns out to be greater than 0, then that variable will tell me how many bytes I actually read from this attempt to read back from the socket channel. It can return a 0, which basically means I did not read any bytes, but try again later. Okay, so right now there's nothing to read back. If it returns a -1, it means we are at the end of the channel. There are no more bytes guaranteed to read. So if it is returning anything other than a value greater than 0, I'm just going to exit the loop because this is once again is a blocking call, and with a blocking call, it is guaranteed that if there is anything to read, it is going to read it and return a greater than 0 value. It will never return a value of 0, but it can return a value of -1 when you're at the end of that stream. So that's why I check whether it's greater than 0 to stay in the loop. When I get out of the loop, I check whether read return value is less than 0. It should be less than 0 all the time. And in that case, I will basically say the entire response is received, and then we can change the state, which notifies the other side to say that we are done with that reception. If we got an I/O exception, we'll change the state to error state. Okay, so this entire thing, everything from line 132 all the way to the end of this part here, which is line 169, would be the things that we need to do in the helper thread. and then we say, okay, helper thread is now active. Let the operating system schedule when it will actually kick in, and return the true in this case, because I want to let whatever the caller is and say that yes, I did accept this particular command to specify a command. So that's basically how it works. On request terminate is not used. Okay, there's no use for that at this point. Are there any questions about what we just talked about? Okay, I think it's important to go back here. Every single time I receive a chunk of bytes, okay, in this case only 4 bytes at a time, I'm going to call state change. State change in return will invoke the onStateChange method of a listener, which in return will call this particular method. And because we are in the receiving response state, so this code will execute as we are getting those response back 4 bytes at a time. And this chunk of code, if you look at this code here, there's a lot of just housekeeping material. The first one is to get the byte buffer back from cisp model, which is basically saying, okay, give me your buffer. The first thing I do is to rewind the buffer itself. Go back to the first one. When you rewind a buffer, it is not the same thing as clearing a buffer. When you clear a buffer, it clears quote unquote the content as well. When you rewind, the content is still there. You're just going all the way back to the beginning. So clear is the same thing as putting one of those big, huge alternating magnet things over your VHS tape to erase the content. That's clear. Rewind is the same thing as putting it into a VCR and just rewind the whole tape. Okay, go back to the beginning, but the content is still there. So after you rewind, then you will have, I pass it as a parameter to update post runnable, which is a class that I define locally here. So let's check that code out. Doesn't do a whole lot useful stuff, okay? So update post runnable is implementing a runnable. It has a local member called my buffer, which is a char buffer, not a byte buffer. What is the difference between a byte and a char? If you ask any C programmer, they will give you a different answer than a Java programmer. What is a byte versus what is a char? The width of a byte is always 8 bits, but the width of a char
is at least 8 bits.
At least 8 bits, but it can be 16, okay, because of double byte characters. Okay, so if you do not do the conversion like this, and instead you use the internal method called as char buffer from a byte buffer, it won't give you the right result. I tried it already, I know.
Second question.
Yep.
You might be a little bit ahead, but the byte buffer that you're referring from the TCP model, isn't this receiving response in the thread of the socket channel?
This is in the helper thread, correct.
So that's in the helper thread. So you pass the byte buffer to the update post runnable?
Yes.
And then you run it with a handler?
Yes.
Isn't that the same buffer that's in the other thread?
Yeah.
And you're going to read it without synchronization, while the other thread's loading it up and ready to call you again.
But the other thread cannot be using this object. Each one is new. Okay, so my buffer is local to a particular object of update post runnable, right? The constructor is called from the helper thread.
So it's not a copy, it's a reference.
Which line are you talking about?
The byte buffer.
The byte buffer is a reference. It is not a copy. But once it gets here, then we are allocating a new buffer for my buffer. So my buffer does not share memory with BB.
But when you say the buffer get, right there.
Buffer get.
Just right there, line 23.
You mean this one?
Yeah, you're reading the other thread's buffer.
Yes.
Without synchronization.
But there's no. But this can only be called within the helper thread. This is not called from the UI thread.
No, you just updated the post runnable, and then you're going to handle it by the my handler post runnable.
But the constructor is not. the constructor is outside of the run method.
Copy that, sorry.
So the run method is down here. Okay, but that's a very good point. I like that, okay? Because that's a very good point, because it can potentially be a big problem if this were to be used, if the code in the constructor is inside run, then we have a big problem. You're absolutely correct. So it really helps to kind of emphasize that this is, okay, the constructor should only be called from a helper thread, but this one is going to be run inside the UI thread. Okay, so it's important to kind of make that distinction. Okay, so this is run by the UI/main thread. So by the time this runs, my buffer is an entirely separate entity compared to the byte buffer from the other object. So we have no problem with that synchronization issue.
I like it.
But it's good. When I wrote this, that was going through my mind as well. It's like, okay, how do we make sure that we can do this? And then the other thing is, you can the UI thread can be very slow compared to the receiving, which normally is not the case. Okay, normally your network connection is going to be the slower one, and you can update the screen faster than you can receive things from the network connection. But even if it's the other way around, this will still be okay, because you just end up with posts that are not handled, that are pending, and it will have like a backlog of posts. But it won't interfere with the networking side. The networking side will keep generating these objects, of update post runnable, and then your UI thread will just have a backlog of things to update on the screen.
4 bytes at a time.
4 bytes at a time, yes. Which can be quite painful. So this whole thing is set up so that they will interact. The two threads can interact without interference. Is that part okay? All right. So there we go. So on state change, is going to create a post runnable. The post runnable is going to be posted, but it won't actually run. In other words, this code is not going to run until the UI thread says, okay, I got time now. What else do I have to do? Then it will go ahead and find out, that it needs to do this. After we do all this stuff here, we have to clear the BB buffer, which basically means, okay, everything in the BB, in the byte buffer, is now taken care of. And once it's all taken care of, by the time we get back into here, there's one extra clear, just to be sure. And at this time, we can go back to the beginning of this loop again to read another 4 bytes, or up to 4 bytes.
And we could have cleared it before we posted the runnable, right?
We could have cleared it in the other one.
Yeah, we could have cleared it at line 42 and then posted it at 43.
42. Yeah, we could do that because
we have a legit copy.
Yep. But the post call is supposed to be instantaneous, so it doesn't really matter whether you flip the order of the clear versus the post. Those two can happen in parallel.
I'm just saying if we cleared the buffer before the post runnable ran, the buffer wouldn't work. But the code
Correct.
works, so it works.
Yep. So the clear has to happen after the constructor, because the constructor needs the content of the byte buffer.
And technically, if we did run it, it probably is empty, right? But not clear.
It's going to be.
We read all the data out of it.
Right. So there's no remaining, but it's not cleared, which means it's basically quote unquote filled up to capacity. So you have to clear it to make that capacity available again for another attempt to read. Okay, so that's basically how this program works. It only works for one single request, by the way, because I did not, change the state properly back to the idle state so that it will be ready for the next request. But it does show you the intricacy of, how to use multi-threading in combination with the MVA model, okay, because you basically have an object that is handling all the communication in the back end. For the most part, you don't have to, in the main thread, you don't have to worry about a single thing. You just start the whole process and go, okay, you go get the HTML document. The only time that you need to know something about it as the main thread is, oh, do I need to update something on the screen? Did you get something that I need to update, on the screen? And we are using the notifier mechanism and the listener mechanism in order to make that interaction possible. So that's the entire program. So I can give you a few sticking points, right? Okay, sticking points. The first one is knowing what permissions are needed, because otherwise the socket channel open would not work. And then the second main sticking point had to do with the debugger not working. Well, not the debugger itself, but when the program crashes out, it does not report back what happened. Okay, so the exception that caused the program to crash was not reported, which basically is then I have to put breakpoints into the program and see, okay, did I get to this breakpoint before the program crashes? And that was time consuming. And then what else? What other sticking points? The main sticking point was really socket channel open returning a null, and it doesn't tell you why, or I did not even suspect that was happening. So later on, when I try to refer to the socket channel member, it would then generate a null reference exception, and the program itself would crash. Except I did not know that was the reason, because I could not even see the message of what is causing the program to crash. Questions? Okay, so I want to double check now to see whether that problem is still here or not. So I'm going to take out these. just make the program crash again.
Because why not?
Sorry?
I said because why not?
Yeah. Well, because I want to see whether the problem is actually because of the setup, the new version of Android Studio, or what. I mean, or was it something that I did? Okay. So when I click start, oh,
It will not let you.
it's not crashing though.
Did you restart the app itself?
I took out the permissions.
Yeah, I tried it earlier, it didn't crash either.
I noticed sometimes you have to actually stop it.
I
Restart
did stop it
before
completely.
build.
Okay, and Android Monitor was not reporting anything. Okay, it's reporting something right now because device state checker canceled. So there's something periodically going on in the background that is generating some ticks like this, at least in my case. So it's micro detection worker in Google quick search box is generating some ticks. And there's a crash. But the app itself, oh, the app itself has crashed too. So this is really suspicious. Okay, let me try that one more time. It really should not get to this point because the socket channel open should now fail. And when I click start, that should fail as well. Ah. Or is this not saved? Once you install an app and you reinstall the app again, would it keep the permission from an earlier installation?
Quite possibly.
Because we are actually, the way the debugger works is actually makes an APK file, send it over, and install it
Right.
before it runs. So if it's maintaining the old permission, then it's not going to have a problem. Yep.
In your emulation, is it reinstalling it or is it uninstalling it?
It's reinstalling.
I'm not sure whether it's reinstalling or is it does it uninstall first?
It installs over.
If it reinstall, then it will only have a problem. It will only let you know when you're requesting new permissions, but I'm not sure whether it will keep the old permissions or not.
If it's uninstalling, then yeah, it will ask for permission.
Okay,
but
so-
it's reinstalling.
Okay, so when we close it, that should make it go away. Because the behavior is not consistent with what I saw last night. The app is not really installed, so it's, if you try to look into the tray, it's not there. But it probably has some sort of persistence. In other words, the ADB server running on the mobile device is tracking something that is, well, we'll see. We'll find out. But at least I got some problems with the new version of Android Studio. Could be can easily be a configuration issue. Yeah, there was one person he's missing because he's sick today, but he was asking about opening a socket connection to MySQL, and that's partially why we talk about this topic. But this is also a good precursor to talk about HTTP connections, which allows you guys to interact with a website. Yep. The HTTP connection thing is actually easier.
Well, this one's difficult because you put the little model view adapter logo
Yep.
on it, yeah.
So if you're going to write a help file and open it from within the app, that would be the way you would do it with the HTTP socket.
You can include a web view object in your activity.
I'm getting a permission denied. I'm getting a permission denied.
Okay. So you should end up with a null reference when you try to open the socket layer.
Yeah, you're gonna switch it back to idle state. That's what happens.
But I was not able to even open. The
You
open
didn't
call would fail.
successfully open.
Right. The open call would fail.
And so the button doesn't work.
Oh, before you even got to the button, it crashed.
Yeah.
Yeah.
Well, it doesn't crash, it just got an exception. You handled it.
Okay.
You put the code in to handle it, so
Right.
you're not seeing the crash.
Well, you have to put the exception code. The exception was caused by the null reference, because I did not check whether the reference of socket channel is null before I use it. So that was what caused the exception later on, was when I used the null reference.
Yeah, and now that you took out the permissions there, you've coded around the exception, so it's just handled.
Yep.
So you did the right thing. Well, except you don't know.
Yep. But the emulator is taking a long time to start. Looks like it's stuck too, because it's no longer changing its.
It's completely hot.
Yep. Okay, close it. And stop it. Oh, okay, I think the whole thing is kind of stuck at this point.
Put mine back together again. We'll have to figure it out.
Because Gradle is waiting for target device to come online. I just, stop that thing. Okay, let's see if I can cancel this. Oh, okay. Okay, let's give it one more try. Has anyone tried to develop iOS apps? Whether that environment is better?
They're different. That one's done with scenes all over the UI. They're both getting into the constraint stuff for the UI. So the whole competition between how you design the UI.
Oh, okay.
The other one, I did one in Objective C and I did one in Swift. The rest of the concepts are almost the same, except the intent. The intent is very unique to Android.
So how do they handle that in iOS? So if you
Scenes.
Oh, okay. Scenes.
Or
Okay.
segues, they call them. Segues and scenes.
So that's
They
how
use
you
a
can.
segue as a transition, which is they're using an intent as a transition.
Okay. So that's how you can designate. Okay, this is what I want to start now.
Yeah, you just raise the segue. It's pretty much like an intent. But,
Mhm.
you're all enclosed in your app. You can't send a message to another intent in another app.
Okay.
Not quite like that. I'm sure it can be done somehow because I've seen like Yelp pop open. Go
But
to a web
can
browser.
multiple apps, all register and say that they can handle a particular desire from the end user, so that when something pops up, it needs an app to handle that. It will give you a
Yeah, I think
selector.
you customize the URL. I think you put your app name in it or something. If
Right.
It's registered.
Same with Android. You can actually specify a URL with the, but in that case, you know what you want to start. Okay, let's say you have 3 browsers installed in iOS, which I assume is possible.
Chrome, Safari, and
Okay.
Opera.
And then you get an email with an HTTP link. So when you click on that link, does it give you a choice, like which browser do you want to use to start? Or does it automatically default to whatever is the system default?
That's probably in the settings and stuff.
Okay.
I mean, this is the same war Apple went through before, right? I mean, Apple versus Microsoft, closed versus open.
Mm-hmm.
You know, now it's Apple versus
Android.
Google, Android, closed versus open. Here
Yep.
they have every set piece of hardware. They know exactly what it looks like. Here we
Mhm.
don't know anything about the piece of hardware we're running on.
Exactly. And we don't know how the manufacturer has tweaked the user interface either.
Or even if you have a user interface. I mean, you could have an Android without a user interface, right?
No.
Stick it inside of a robotics.
I suppose.
The core of Android, not necessarily the UI.
Oh, okay.
Or Android, you're going to need to end up using a Linux kernel.
Well, then you wouldn't have any Android calls.
Right.
Intents, you wouldn't have. So if you have intents and say, move the motor arm,
Mhm.
roll the wheel, you really wouldn't need, some
But-
UI on the top of something that has a radio sitting on
That's
the
Right.
kind of what makes it Android, though, is the UI. Along with parts of.
Well,
Well,
I think the main value of Android is the UI.
yeah.
Well, besides the UI, it does add the interface or a whole framework to deal with Google services.
Right.
So that's the other part that is really useful, is when you look at the Android classes, there is a pretty big chunk of it to deal with Google API.
Oh, yeah.
So if you want to use Google Sign In with your robots, you can do that.
Well, Android's the message pump. I mean,
It's a
fundamentally,
message pump.
it's the message pump that's picking up events, intents, whatever, and delivering them to the task at hand. And some of, we like to have a skin on top of it, have a user interface, and have
Mhm.
some events coming in, but that's just in a sense like an application sitting on top of the Android.
Mhm.
The Android's the one that's able to do all the intent. So if you put it on top of robotics, or you put it at an Internet of Things,
Mm-hmm.
if you wanted to use Android to customize your, I'd say microwave, but then you'd say I have a user interface, but not a Google, and not a GUI,
Mm-hmm.
right? I mean, so you
To
can
a
pick
certain
up all the
extent,
buttons.
the robot itself would be the interface, though.
Well, it's not sitting on top of Linux. I mean, if I was sitting on top of Linux, I'd have to write different code.
Well, no, it isn't sitting on top of Linux. Linux
Well, the
is kernel.
VM is sitting on top of Linux, but your Android app is sitting on top of the VM.
Yeah.
So you're basically looking at a stack where you have your Linux at the bottom. Okay.
There's actually a really good image, I think, online that shows
Hmm?
it. There's a really good image online that shows
Oh, okay. Yeah, we can look for that.
Yeah.
Pretty sure there are quite a few pictures to illustrate the layering. So Android, Linux, stack, and then just look at images. That should give us something. Woohoo! This may not be a bad one. I like this one too.
That's I think you use that one with the 362 class.
Yeah, I think there are a few like this, but they're all similar in terms of what they illustrate. So the Linux kernel is sitting all the way down here, and then the Java, the VM itself is sitting on top of the library.
Over in the.
It's basically between these two, between the application framework and the library is the VM. Huh?
Yeah, so
Right.
Android's really Dalvik, is what I'm referring to.
Sorry?
The Dalvik virtual machine.
The
Which
what?
is the Dalvik virtual machine,
Uh-huh,
which is
yeah.
which is what I would be referring to as the core of Android.
Right, where the pointer is pointing to?
Yeah. And the rest of it's, they're all just kind of libraries.
But the VM is also, who is responsible to kick out activities that are not active anymore and when you run out of memory?
Well, the operating system's on the bottom, so Linux. But I'm saying if I wrote an application, I wouldn't need a user interface for Android.
Right, right.
Yeah, I mean,
Yeah, you can write an app without a user interface.
Yeah.
That launches automatically when Android itself launches. Because once you have the intent and also the manifest for the apps, you can specify which ones start with the OS. And then once that starts, it can have its own intent to start up additional Android apps. So you can have your own, kind of collection of apps, and they're all UI-less, in an Android system. The big question is, what is the value of, basically a skinless or UI-less, Android system? Is the rest of the library offering enough incentive to make it useful? That's the
but just
question.
background communications. What do you say, for example, roaming? You have like
Sorry?
background tracker.
Mm-hmm.
But then you'd say, well, don't you want to see the output?
Right, exactly. But I can see how it can be valuable, because when you look at the Android classes, still a good portion of the Android classes are, in the background, they're specific to Android, Google services. So when you look at, this is a huge list.
Which they also have most, I think except for the Play services,
Mm-hmm.
all the other Google services they have dedicated straight APIs for, separate from the Android ones. So then the question becomes, do you just use a Linux kernel and then call straight to those APIs as opposed to the Android
Okay,
framework?
let me add one more thing, because once you go through the Dalvik virtual machine, you can also leverage just regular Java classes and Java libraries. So that itself may be an incentive to use Android instead of Linux. But in native Linux, you can also use OpenJDK.
Yeah.
If the Oracle libraries is all that you need. But on top of that, if you also want to use the Android specific libraries, for the various APIs, if you need to, okay, good example, especially for those in cisp362. If you want to use Firebase DB, well, guess what? If you try to do it without going through Android, it's going to be a little bit more trouble, because it doesn't have, the API is not available, or it is not available in the form where it can integrate with your Java programs. So there might be some values there, but I think
Well, just think if I wanted the access to GPS, but I just want to build a little tracker.
right.
I wouldn't need the user interface. I wouldn't want to go to Linux, because I don't want to talk to the device. I'd rather just hook up to the GPS location.
So it gives you the
and then-
convenience.
Yeah, so.
Yeah. And also on top of that, it also hooks up to the Google Maps API, where you
So
can
now I
get
can
it
show
can
my
get you the
location.
address directly.
Reverse geolocations.
Yep. So there's some value to that, but then the overhead is the other part you have to consider. Is if you need to fit the entire thing into a small resource, not resourceful environment, then you have to look at what this particular layer is adding on top of a native Linux system. I wonder if anyone has done that with Raspberry Pi. Put an Android layer on top of a Linux. Raspberry Pi Android. Okay, so the Android source repository gets a new device tree for the Pi 3. So there you go. This is interesting. I like it.
So it's an official Android Raspberry Pi.
So it seems, because it's Google who is bringing the official support. So this is
Yeah.
not a.
Third party,
Yep.
Hackadroid.
Well, there are a lot of hackers, working for Google, so.
Yeah, but this one's officially sanctioned by them.
Yes. Well,
As
yeah,
opposed
but
to just having Googlers
but
doing
Google
it
has
as a
been
side
known to
project.
pull support from certain
Yeah.
projects, like like after a while.
Oh yeah, they do it all the time.
Well, since we're on this topic, some of you may be interested in this Apple Google patent diagram. Okay, that should find it. No, this is really interesting. Let me see if it's already indexed here. Nope.
Might have
Well, you
to
can get
like
those pies
Oh,
for
there we go.
$35.
Oh,
Hmm?
You can get a pie for $35.
You can get one for $5 now. $10.
You
if
can,
want
you cannot even
wireless
get a
and
real
Bluetooth.
pie for that.
Yeah.
I give you $5. Can you buy me a pie? No. Now this is.
comes with Wi-Fi and Bluetooth. Google the Pi Z.
Mhm.
It's called.
Yeah, this is interesting. They plot the connectivity of patents. So basically these points represent inventors or owner of patents, and they use a line to connect co-authors of patents. So for each company, on one side, on the left-hand side, you have the map for Apple, and then on the right-hand side, you have the map of Google. So what they found was, with Apple, most patents, have there's a high frequency of occurrence of common contributors. So they're basically core patent creators in Apple, but in Google, it's a lot more flat. I think they accounted for a small number of people working for Apple accounts for the majority of all the patents, as opposed to in Google, it's really flat. Like 8,000 people contribute to about 12,000 patents. As
So in
opposed
Apple,
to,
you have to give your rights to the guy that's signing off with your patent, and in Google, they let you file it by yourself.
I think in both cases the company eventually owned the patent.
Yeah, I'm just saying you would always sign off on every patent, and that makes you one of those concentrators.
Ah, okay.
So we have to all bring all patents through you. And in
Oh.
Google, we can go off and just apply them in the company.
Possibly. I'm not sure, how the internal structure works.
No, I'm just saying that's what the concentration is. All of a
Okay.
sudden, your name's on every patent. That
Mhm.
makes you the dark center.
Right. The dark center.
Dark center.
But this is kind of interesting because it kind of shows you the structure of each company. Google at one point was trying to go completely flat without management. They tried it for a very short amount of time and then very quickly realized, no, we need some kind of structure. Yep, it does not work. But Apple has always been a kind of structured company. Yep. Yep. So there we have it. So I'm hoping you guys enjoy the discussion of sockets, threads, and be able to kind of make use of that somehow. You have experience, working with threads and sockets already, so it's just a matter of figuring out what class
I
to
can't
use.
figure out when we'd use multiple clients of the same thread.
Multiple clients of the same thread.
Yeah, I can't think of it.
Multiple listeners, you mean?
I mean, I could see multiple listeners, maybe like if I wanted to throw up an alert or something when it shows.
Right.
But to handle all the events, to filter it out.
I'm not sure which aspect you're talking about.
I just always have one client on any socket I've ever had.
One client for every socket from the
I'm-
client
yeah,
side.
The way I'm servicing it locally, I'm
Right.
picking it up, and other things may happen at a higher abstraction.
Mhm.
But at the very lowest level, at the socket, I've never had somebody else get in there and say, "Hey, is it connected yet?" I guess I could come up with an app though.
But the idea is to have only one thread. Well, the idea is to have a helper thread so that anything that can take a long time, you offload that to the helper thread and not have the main thread to have to deal with it.
Correct. Yeah, I got that. I'm saying
Right.
the listener structure with multiple listeners to a single socket.
Oh, I see.
Yeah, okay, are we ready to write? Or are you going to write? You want to write? Although it does say the socket will allow multiple threads to write, and each one will complete before the next one begins. So I can see the power of it. I just can't get my head
I
around
can
it.
see. Okay. So now I know what you're talking about. Okay, I see what you're talking about. You're talking about this part here. where I broadcast the event, the state change event to
Correct.
whoever wants to listen,
Multiple
right?
listeners.
Multiple listeners. I can see, you can have multiple elements on the screen where one is actually displaying the content of what you're receiving. Only one can do that because you're clearing the byte buffer in that case. Although you don't have to clear it, because the clearing can also be done at the very end. So each listener can rewind it and actually get the content. Do you see what I mean? You can have something on screen,
But
okay?
they all
You
have
know,
to be in the same.
they will all be executed
all
by
be
the same
executed
thread,
by
but they
the
can be
same-
different objects. So one can be relaying that to a Bluetooth device, the other one can display on the screen,
Or I could put myself a little transmit receive lights up there on the top.
and one can be a little transmit receive blinky light. And they are now, but in terms of coding, they're all pretty much independent. The only part they have to that is in common is they all have to get through the interface of a on state change listener and register with the simple TCP model. So it doesn't hurt too much if the overhead of maintaining a list of only one item is not too bad. Any other questions, comments? As I write this up, yeah, go ahead.
I was just wondering, so when you have the void, public void run, if you have it public, does that mean?
It has to be public.
I know you said it has to be public, so does that create any confusion? Like if you had to run in main and run in your simple TCP Java, if you just said, if you were just call run somewhere, how would it know? You have to worry about that at all if you're making public methods?
Well, the public means whoever gets a hold of this object, the object is created by this new thing. So whoever gets a hold of this object can call the run method.
Okay, so it's more like a permission rather than a scope thing?
It's a permission thing, but it's something that you only worry about when it is time to run it from this method, from this object.
Yeah, it's a method. It's a method on and off.
So it's still just local to just that?
Yes,
level?
correct.
To that object.
To the anonymous class that describes that object, yes. Because every object has a class associated with it. It's just that some classes are anonymous without a name, because we don't need it to manufacture multiple objects from different places of your program. But it still has a class associated with it.
They have an instance,
Right, an instance.
but anonymous instance.
Yep. Well, an instance of an anonymous class.
Yes.
But when the Java virtual machine says, okay, object blah 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 with a reference, and say, okay, I need you to run your run method, it will still have to go through the checking and see whether the run method should be visible or not, and the public makes it visible to whoever needs access to the run method.
We do that in compilation.
Hmm?
We can do that in compilation.
Yes, you can do it in compilation, but one of
the
the
public, it'll fail.
you can, well, if you take out the public, it will fail for sure, because the interface itself requires that to be public. But on the other hand, even if you use interface, everything that you specify in the interface has to be public. It cannot be non-public. If you try that, okay, I have one here, right? We have one interface definition here. If you take out the public,
It'll still work.
does it?
Yeah. It's got to be public. You just said it.
So it is by default public already.
It's got to be. It's the only choice, right?
Yep, doesn't like that. Yep. So it's already by default public. It doesn't have to be spelled out as public.
But when you implement it, you have to implement it as public.
Right. Because it is implicitly public, so when you implement it, has to be public. And I think it's also by no, never mind. That part is not true. I was about to say static. It's not static.
Modifier public is done for interface method.
Say that one more time.
I was reading the bottom of your screen. It says modifier public is redundant for interface method.
at the bottom of my
That's
screen.
quite
On
redundant.
the Android Studio,
Uh-huh.
modifier public is redundant for
Yeah,
animation.
yeah, okay. It is smart. Yep, this is one of the first. I have used Eclipse before, but I think Android Studio does a bit more than Eclipse
Yeah.
did.
Isn't this on the Eclipse skeleton? Is it?
Nope, IntelliJ.
Probably they have some shared code. I mean, it does have that kind of feel to it.
Yeah, it reminds me of Eclipse, but I mean,
Mhm.
10 years ago. Something
You're
like that.
talking to a guy who only used VI for everything. Yeah.
That reminds me of another question.
Yeah, go ahead.
I saw some lessons in here that look like they're from 2014 or something.
Homeworks to do?
Did we miss them?
No, no.
No, we just didn't.
Are they?
No, those
old?
lessons were from the previous time that this class was offered, which was 3 years ago.
Alright.
This is one of those classes that even though it's the same class, each time it's offered is a new prep.
Yeah, it's got, well, look how many updates.
Well, I suppose if I want to kind of be lazy, I can only talk about things that are supported by API 1 only.
Do you know
I love
somebody
how
found a mouse here last Monday?
If anyone did, it's going to be in room 152.
Two?
No, 152.
Yeah,
Yeah, over the counter, just tell them that you lost a mouse in room 125.
And I still have the dongle for it, so nobody else wants it.
But the dongle is not unique. Those things can repair with a new dongle.
Oh yeah, I've done it.
All you have to do is plug it into the device. Like,
Yeah,
How do you-
well, you have to use the software and have the software to look for new devices.
Some of them are really
It's
good. They
doable.
have a reset button on the bottom. It makes
Mhm.
it really easy. You just go.
You can
and it
repair
pairs.
it.
As long as it's the same brand.
Ah.
I have a couple Logitech mice. I don't even bother changing the dongle. I just reset it.